Okay, let's quickly talk about the letter E and where it comes from. And you're not asked to derive it or anything like that, but it's pretty important. So the idea E came from banking. The book has a different take on it, but E came from this idea of how money grows. And so the idea of interest is that let's say you put $1,000 in the bank, and well, actually, this is from the growth and decay. So either money is increasing or decreasing at a rate. So let's say back in the day, you put $1,000 in the bank, and it collects interest every year at 7%. And so the idea is we're increasing it by 7%. So after 1 year, you have $1,070 in the bank. And the idea of compounded interest is that after another year, they take that 1,070 and increase that by a rate of 7%. And so we turn on our calculator, and we have, let's see, 1,070 times 1.07, and we get like 1149. And we can do that repeatedly over and over. We take the second year, we take 1149 and multiply that by another 7%, and we have 1.07. We have $1,225, and we see the money is increasing over the years. And so the idea is we can set up a formula that's 1,000 times 1 plus, a rate, times to the t, or the time period, right? And so the question is, can we compound the money in a different way? So, for example, if I compounded this like once a year at 7%, maybe I can compound it twice a year at 3.5%. So it can be compounded, for example, like semi-annually. So that we're going to introduce a new variable, n. We're going to call it 2, and so it looks something like this. So instead of doing 7%, we're going to do 3.5%, but we're going to do it twice a year. I'm sorry. So the original question assume that we're looking to do this for 4 years, right? So what would the answer be? 1,000 times 1.07 to the 4th power. And so I apologize for that. So we have 1,000 times 1.07 raised to the 4th power. After 4 years, you have $1,310. Sorry. Okay. So instead of doing it once every year, I'm going to do it twice a year, and that means I'm going to do it 8 times. So you're thinking, oh, well, if that's to the 4th, this to the 8th power, the money must be like really big. But you discover that 1,000 times 1.035 raised to the 8th power is simply 1316.81. Well, if I can do it semi-annually, I can do it quarterly, which n equals 4, right? So I do 1,000 times 1.07 divided by 4, and instead of 8 times over the 4 years, it's not going to be 16 times. And I'm thinking, you know what? This is going to be a really big number because I'm raising something to the 16th power. But you notice, let's see, 1,000 times, open parentheses, 1 plus 0.07 divided by 4, close parentheses, raised to the 16th power. This number is going to be really big, right? Not that much. 1319. Well, if I can do it quarterly, I can do it monthly, right? I can do it monthly, and n equals 12. So if my money is $1,000, I'm taking my rate, I'm dividing my rate by 12, But now I'm doing it 12 times a year, or 48. This number is going to get really big, right? So I do 1,000 times 1 plus 0.07 divided by 12, close parentheses. I'm going to raise this to the 48th power. 1322.05. So the numbers aren't getting out of control. They're actually, a word that I'm going to introduce, they seem to be convergent. Because if you think about right here, this was what? This a change of 6, and this was a change of 3, and this is like a change of like 2 plus. This is almost 21. So the changes are getting smaller. So I want you to think about, what are we theoretically doing here? What's going on with my n? What's theoretically going on with my n? Well, you would say, Mr. Adler, we're theoretically going to infinity. What happens to this number as we go to infinity? Theoretically. Because that's what we're doing in this math class. We're mathematicians. We're thinking abstractly, theoretically. So let's take a look at this formula. We have the 1,000 times 1 plus the rate over the n times nt. Right? What we're going to do is we're going to let k equal 1 over n, r over n. No, sorry. We're going to let the r over n equal 1 over k. Once again, I'm not testing you on this. This is just how we're going to arrive at what e is. We're going to substitute r over n with 1 over k. Then we're going to do some cross multiplication. We're going to say that n is equal to rk. So we're going to rewrite this formula as 1,000 times 1 plus 1 over k. I'm going to write this as kr. We have krt. And what we're interested in, what happens with this part here as k goes to infinity. Right? So what I want you to do is I want you to take your calculator and I want you to start at 1. So if k equals 1, then we have 1 plus 1 over 1 to the first power. That's 2. Let's move towards infinity. Let's make 10k equal 10. 1 plus 1 over 10 to the 10th power. What's going on over here? Let's see. 1. Let's see. 1.1 raised to the 10th power. 1.1 raised to the 10th power. We have 2.593. How about we say k is 100? 1 plus 1 over 100 to the 100th. What does it say in your calculator? 1.01 raised to the 100. We have 2.70481. Let's keep going. How about we do 1,000? How about we let k equal 1,000? We're getting closer to infinity. 1 plus 1 over 1,000 raised to the 1,000th power. So, how do we do the decimals? Or, we're just using 1 plus 1 divided by 1,000, enter, and then raise that number to the 1,000th. We get 2.71692. We're converging to something. It's getting closer. How about we do 1,000,000? How about 1 plus 1 over 1,000,000, and raise that number to the million? What do we got? Let's see, what do we got? We got 1 plus 1 divided by 1, 0, 0, 0, 0, 0, 0, enter, raised, hold on a second, 1 1 plus 1 divided by 1, and then raise that to the millionth one. 2.71828. And this is interesting because now, what does this number end up being? As k goes to infinity, 1 plus 1 over k to the kth power equals e. And that's this number e. And so when we set, we're not setting it this year, but when we have a rate, we call it compounded continuously. Compounded continuously. And if you think about it, like many things that we study actually compound continuously. For example, like the death rate of animals, or the growth and death rate of animals. So for example, like when we say like the animals died at a rate of 7% per year, we don't mean every single animal died on December 31st. The idea is that it's constantly changing. It's continuously changing. Or when we say like the growth rate, the birth rate is like 8%, we don't mean that every single baby was born on January 1st. We mean that over the entire year, the rate is growing continuously. Now, this number e is 2.718. It's just a number. It's like pi. It literally is like pi, where pi is 3.14 and it repeats. I mean, it doesn't repeat. Same idea with oh, is my battery dying? I'm good. It's the same idea with e. And so e is just a number. So, so what's e plus e? 2e. What's e times e? E squared. What's e divided by e? 1. What's 5e minus 16e? Negative 11e. That's it. Once again, it's just a number. It's on the number line. Here's 0, here's 2, here's 3, here's 4, there's pi, there's e. That's all it is. Thank you.